We have a right angle triangle, and on each side, a semicircle is drawn. With that side of the diameter. The area of the three semicircles are x squared, 3x, and 180, where x squared and 3x are both less, which means that this area is going to be 180, and I can call this one x squared and this one 3x. It doesn't really matter which is which, but it's important that that one's 180. We're then asked, what is the area of the smallest semicircle? Well, we know that we know Pythagoras' theorem. A squared plus b squared equals c squared. Now that is for the area of a square. In fact, if you find the area of the squares, when we draw these on, then they will be equal. But the area of the semicircle will equal a half pi r squared, and the area of each square, if r is the radius, then the area of the square will be 2r squared, which is 4r squared. And therefore, in both cases, the area is proportional to r squared. And actually, the same kind of idea, Pythag, will still apply for the circles, is what I'm trying to get at. Or the semicircles, I should say. Now, I've not gone into loads of detail on it, and I'd say like look at the work, the full solutions if you want to do that. But I hope I've convinced you. I've put these semicircles on. I've said a squared plus b squared equals c squared. I've written down the area of the semicircle and the area of the square. We see they're both proportional to r squared, and that means if that is the case, then it must be that will apply for both, because I can, whatever I have, um, if I divide, if I have Pythagoras' theorem with r squared in it, then I can just times by pi, divide by 2, divide by 4, and I'll get the area of the semicircles. I think I've said that right. And therefore, I can simply say 3x plus x squared is equal to 180. And the hope in this question is actually that you figure that out pretty quick. It's got to be that. And now we've just got a quadratic to solve. X squared plus 3x minus 180 is equal to 0. I'm going to factorize it. If it's going to factorize, then the factors have got to be quite close to one another to get 3 here. And actually, with a little bit of thinking about it, we get 15 and 12. X plus 15, x minus 12 equals 0. So x is going to have to be a positive. X is equal to 12. Now we're actually asked for the area of the smallest semicircle, so I can see I'm going to get 36 here. I'm going to get 144 here. It's 36 that's going to be the smallest. So our answer is 0, 3, 6.